I just like the sound of it.
Yo, what's going on? I'm back again with another video. I'm going to go over this quiz review, and I hope it helps. Let's get started. Alright, right here, we have three functions. Alright, and we need to evaluate them for the operation sign present. This first one here, this is the function f plus g. Alright, so we're going to take f and g and we're going to add those together. So we have the function f, and we're going to add that plus g, the function of g. Remember, when you add, you combine like terms. So we have 2x squared plus x squared. That's going to be 3x squared. We have 5x. That's the only x to the first term. All right. So 5x. And then we have negative 8 plus 6. That's negative 2. So 3x squared plus 5x minus 2. Next, we have f minus g. We have f minus x squared plus 5x plus 6. That's g. Remember, guys, the first thing you need to do is distribute that negative. All right, distribute that negative to everything that follows. So we have 2x squared minus 8. Minus x squared minus 5x minus 6. From there, combine like terms. 2x squared minus x squared is 1x squared minus 5x. And we have negative 8 minus 6. That's going to be negative 14. Alright, next, f times g. Alright, right here we have the function 2x squared minus 8. I'm going to multiply that to x squared plus 5x plus 6. Remember, here you need to FOIL it or expand it out like this. I like expanding it, guys. I really do. Let me make this a little thinner.
I just like the sound of it.
Alright, cool beans. So we have 2x squared times x squared plus 5x plus 6 minus 8 times x squared plus 5x plus 6. Now, there we go. Let's distribute 2x squared. So 2x squared times x squared is going to be 2x to the fourth. 2x squared times 5x is going to be 10x cubed. And then you have 2x squared times 6 is going to be 12x squared. Now, negative 8 times x squared is going to be negative 8x squared. Negative 8 times 5x is going to be negative 40x. And negative 8 times 6 is going to be negative 48. Now, what we need to do is combine like terms. So we have 2x to the fourth. Alright, then we have 10x cubed. That's the only cube term. So 10x cubed. We have 12x squared minus 8x squared. So 12 minus 8 is going to be 2x squared minus 40x minus 48. There we go. F times G. Oh man, actually look, I just noticed a mistake I made. Right there. 12 minus 8 is 4. There we go. 4x squared. Sorry about that. Alright.
I just like the sound.
Now we have f divided by h. Alright. Now, don't forget the restrictions. Your restrictions. Well, let's write this out. The function f divided by h. 2x plus 4. Alright, so we have 2x squared minus 8 divided by 2x plus 4. Alright, that's h at the bottom right there. Is it 2x plus 4? Yep. So first of all, I want to address this restriction, guys. To find the restriction, take your denominator. Set it equal to 0 and solve for x. Alright, take your denominator, set it equal to 0. We're talking about the restriction here. Alright, and we're going to set it equal to 0 and solve it. So subtract 4 on both sides. Alright, and then divide by 2. So you have x equals -2. That's the restriction. Actually, you know what? Hey, I'm going to set all these not equal to. Sorry about that. Set it not equal to 0, not equal to 0, and solve it. So when you set it not equal to 0, x cannot be -2. Because remember, if I put -2 here, 2 times -2 is -4. -4 plus 4 is 0. So you can't have 0 in the denominator. That's undefined. Okay, so anyway, now let's go and simplify this. Alright, remember what I said? We want to factor everything. Okay, factor everything. So when I factor this top, alright, it's going to give me, I'm going to factor out 2, the greatest common factor. So I factor out a 2, I'm left with x squared minus 4. And then down here, I'm going to factor out the greatest common factor. And I'm left with x plus 2. Now, this right here, guys, is the difference of 2 squares. Alright. With the difference of 2 squares, remember, we can factor that again. So we have 2 times x plus 2, x minus 2. And down at the bottom, that doesn't factor anymore. So it's just 2 times x plus 2. Alright. Now, what can we negate? So let's go ahead and cancel out the same terms. Alright, and we're left with x minus 2. So we have x minus 2. And then don't forget your restriction. That's a semicolon, guys. Alright, that's not an I. Alright. There we go, x minus 2. And where x is not equal to -2. There we go. X is not equal to -2. So there is our solution right there. Okay? Alright, moving along right here to 5 through 8. Alright, I don't know why it's just 5 through 8. It should be 5 and 6. Anyway, we're going to evaluate f of g of, or we're given f is 4x plus 3, and g is -x squared minus 2. Man, sorry, y'all. Find f of g of -4. So, let's go and dig in. G is the internal function, f is the external function. Alright, so it's a composite function because one function is in the other one. Except here, x is defined as -4. So we have g of -4. So I'm going to evaluate that first. The internal function first. Remember, PIM does parentheses first, do what's inside. So g of -4. Alright. So I'm going to plug in -4 right here. Oh, excuse me. Into the function g. So I have -4. Remember, that negative right there is already a part of the equation, okay? They're already a part of the equation. Now I have the -4 squared minus 2. Here, let me move this. I don't want this to confuse anybody. Has nothing to do with this problem. So now, -4 squared is positive 16. Alright, -4 squared. That's -4 times -4. That's positive 16. So -4 squared is 16. And then I have this negative out here. Well, negative 16, that negative makes this a negative 16. So negative 16 minus 2 is going to be negative 18. Okay? So now I evaluated g of 4, negative 4 to get negative 18. So now I have f of negative 18, right? Because g of 4, that is negative 18. So now I'm going to evaluate f of negative 18. So I take this right here. 4 times negative 18 plus 3. And 4 times negative 18 is going to be negative 72. Alright, excuse me, negative 72. And plus 3, negative 72 plus 3 is going to be negative 69. So negative 69, guys, f of g of negative 4 equals negative 69. Alright, so now let's do the next one. The next one says g of f of x. Alright, so with g of f of x is a composite function. Alright, so this is just saying x is not defined as anything but x, so it will remain x the entire time. But we are going to place the function f into the function g. So what we have here is negative 4x plus 3, because again, we're putting f inside of g. Alright. So there we go, we plug it in. Alright. So now we have 4x plus 3, we're going to square that. So we have, remember when you square it, remember that means write it twice. Alright. So now you're going to FOIL here. So you have you have 4x times 4x, that's 16x squared. 4x times 3 is 12x. 3 times 4x is 12x. And 3 times 3 is 9. Alright, we still got this negative out front. And it's minus 2 outside. Now simplify this. We'll go right here. We have negative 16x squared plus 24x plus 9. Alright, minus 2. And then here, I don't want to confuse anybody, so let me get rid of some of this. Alright, there we go. So now distribute the negative. So you have negative 16x squared minus 24x minus 9 minus 2. And then like terms, negative 9 and negative 2 gives us a final answer of negative 16x squared minus 24x minus 11. Alright, minus 11. Right there. Alright, so final answer right there, okay? Alright, now, for this next problem, it says from the graph, determine if the relation shown is a function and if the inverse is a function. Alright, this right here, we want to use two tests. To determine if it's a function, you use the vertical line test. Alright, to determine if this graph, this relation, is a function, we use the vertical line test, meaning a straight line, vertical. Boom, that's the vertical line. Alright, so I want to do a vertical line right here. Alright, vertical line test. I draw a vertical line, and you could draw it anywhere. Alright, anywhere, it doesn't matter. Alright, look at the vertical red line. Even this one. How many times does this red line touch that relation? Right there, that's relation. Touches once. Even right here, it touches one time. Even right here, that vertical line touches one time. So with that being said, guys, the vertical line test proves that this graph is a function. All right, it is a function. Oh, wrong thing. This is a function. All right. It is a function. The vertical line test, all right, touches only one time. All right, so that proves it is a function. Okay. Now, for the graph's inverse, all right, for the inverse, we use the horizontal line test. All right, horizontal line test. And with the horizontal line test, all right, you draw a horizontal line like that, a horizontal line, all right, to determine if it's inverse. Its inverse is a function. Okay, so here we go. Horizontal line test. Oh, not that big. That's big. All right, here we go. Horizontal line test. All right. Oh, wrong thing. Sorry about that. Boom. There we go. All right, horizontal line test. I don't know what just happened to this thing. All right, don't worry about it. Here we go. Horizontal line test. Boom. Horizontal line. And it doesn't matter where you draw it. All right. Okay. Look at this black line right here. How many times does that touch that relation? See that relation? How many times does that touch? All right, that touches multiple times. All right, this one touches more than once. Because it touches more than once, all right, that means this is not, its inverse is not a function. All right, it's not a function. All right. If this were to touch once, its inverse would be a function. But because it touches more than once, it is not a function. Okay? It's not a function. So, now, which type of line test determines if a relation's inverse is a function? Well, we just did an example. All right? It goes, which line test determines if a relation's inverse is a function. All right, we were talking about the graph's inverse. All right, we use the horizontal line test. All right. Now, all right. Hey, I'm gonna actually stop right here. The video's longer than I expected, so I'll make it a part 2, okay? And I will catch you on the next video.